Hi all, good morning. Today in this offline mode, we will be discussing about telescopes. Last few classes, we are discussing about different types of galaxies, different types of stars, star formations, etc. All these are visible to human eye, it's clearly visible to human eye only through telescopes. We have learned early that Galileo is the first person who used this telescope to view the celestial objects. Actually, Hans Lippershey, a German spectacle maker, was the first who invented telescope. Galileo was the first person who started to observe celestial bodies using telescopes. Actually, he was a loud and persistent voice over the years, and his amazing string of discoveries using his crude instrument pays off. Okay, we can now let us move on to more concepts about telescopes. We know telescope is actually a tool that astronomers use to see faraway objects. Most telescopes work by using curved mirrors to gather and focus light from the night sky. The first telescopes focused light by using pieces of curved clear glass called lenses. You might have studied about these lenses during your high school classes. Then why do we use mirrors today? Because mirrors are lighter and they are easier than lenses to make perfectly smooth. The bigger the mirrors or lenses, the more light the telescope can gather. As an example, if you take an example of a bucket that can be filled with water, we can fill more water if the bucket is big, isn't it? Like that, we can collect more light if our mirrors and lenses are bigger. The light is then concentrated by the shape of this optics. That means the shape of that mirror or lenses. That light is what we see when we look into the telescope. There are different types of telescopes. First one is optical telescope, and the light is gathered by using lenses or mirrors. There are other types of telescopes like radio telescopes, infrared telescopes, X-ray telescopes like that. The telescope is actually collecting radio waves or X-rays and etc. for getting information from the space. Here, optical telescopes actually gathers light only. It gathers and focuses light mainly from the visible part of electromagnetic spectrum to create a magnified image, or to make a photograph, or to collect data through an electronic image. Even optical telescopes can be considered to be of three types: refracting, reflecting, and catadioptric, depending upon the nature of the objective that used there. We can move on to these telescopes further. Here in refractive telescopes, lenses are used. In reflecting telescopes, mirrors are used. Catadioptric telescopes are actually compound telescopes in which both mirrors and lenses are used. This is a little more complicated one. We can discuss more about refracting and reflecting telescopes. So what are the specifications of almost all optical telescopes? Or what are the main things that we should know about these optical telescopes? First one, as we said, objective of a telescope. Here objective means is not the meaning of aim, but it is having a meaning of that any part which collects light or which gathers light in a telescope. So objective can be defined as the part of the telescope that gathers light. As we said earlier, a refractor telescope uses glass lens as its objective. Glass lens is placed at the front of the telescope and light is bent as it passes through the lens. You might have studied the concept of refraction in your school classes. Refraction is what? The process of bending of light when the light ray passes from one medium to another. The best example is when we dip a spoon inside a glass container with water, we can see that spoon will be bent. That is a perfect example of a refraction. So what is a refraction? Phenomena of bending of light or deviation in the path of light when the light beam travels from one ray to another. In reflector telescope, mirrors are used as the objective. The mirror is placed close to the rear of the telescope and light is bounced off as it strikes the mirror. Reflection means phenomena of deviation of light beam to the same medium. Next one is aperture. Aperture is actually a small opening, or it can measure the amount of light that a telescope is able to gather. The larger the aperture, more light that enters the telescope. This is actually determined by the size of primary lens or the mirror in your telescope. A larger aperture allows the telescope to capture more light, resulting in a brighter or clearer image. Next one, you have to study that the term called focal length. Focal length is the distance between the lens or mirror and the point at which the image of the object is in focus, while longer focal length generally result in longer telescopes. It isn't always the case, as some types of telescopes can manipulate the path of light. There is an internal arrangement inside the telescope so that they can form a image even with a smaller telescope. A telescope's focal length is important in that it determines by what factor your telescope magnifies. Actually, how much magnification is needed is determined by the focal length of the lens or mirror. So magnification of a telescope can be calculated by dividing the focal length of the telescope by the focal length of the eyepiece being used. Next we can move on to diffracting telescope. As we said earlier, refracting telescope is nothing but a telescope made with lenses. A lens, just like in eyeglasses, bends light passing through it. In eyeglasses, this makes things less blurry, isn't it? But in a telescope, it makes faraway things seem closer. People with especially poor eyesight need thick lenses in their glasses, and big thick lenses are more powerful. Same like that in telescopes too. If we want to see far away objects, celestial objects, we need a big powerful lens. But actually big power lens is actually a very heavy thing. Very heavy lenses are hard to make and difficult to hold in its right place. This is actually the working of a refracting telescope. We can see that light is coming from a distant galaxy. We can see like that picture here. The light is coming from a distant galaxy. It falls on the objective of the telescope And in refractive lenses, it is a large lens. It gathers light and it bends the refraction of light happens based on the focal length of the lens. It focuses at a particular point inside this telescope. An eyepiece brings the bright image from the focus and magnifies it into the size of your eye or eye's pupil. This is actually the simple working of a refractor telescope. You can see this and study. I can say once more, light coming from a distant galaxy falls on the objective of the telescope, and the refracted image lens is the objective. It gathers maximum light, and how much this is open to the light is termed as that aperture. Depending upon the aperture, it gathers more light, and there the refraction occurs, and depending upon the focal length, it focuses to a point, and the eyepiece collects or brings the bright image from the focus and magnifies it to the size of our eye's pupil. Okay. Next term is reflecting telescopes. This is nothing but a telescope that uses mirrors. Unlike lens, a mirror can be very thin. A bigger mirror does not also have to be thicker. Light is concentrated by bouncing off the mirror. So the mirror just have to have the right curved shape. No worry about the thickness or the apertures of mirrors. Actually, it is much easier to make a large near perfect mirror than to make a large near perfect lens. Also, as the mirrors are one-sided, they are easier than lenses to clean and polish. But there are certain problems for mirrors too. We have already said that example of a spoon's reflection. We can see that it is inverted or it is upside down. The curved mirror is a telescope, is less like a spoon, it flips the image. How can we solve this problem? We can solve this problem by using some more mirrors attached inside the telescope. We can use additional mirrors to compensate for that flipping or that inversion of the image. Again, it falls on another mirror, and that inversion becomes solved. We can see the working here. Light falls on a small mirror. Light falls on a large mirror that is placed at the far end of the telescope, and from there light is reflected, and reflected light is collected to a secondary mirror, and from there it reflects to our eyepiece, and thus eyepiece brings magnified image to our eye's pupil. So large mirror gathers and reflects light, and from there it falls on a secondary mirror which reflects light, so that inversion problem is solved. When this small mirror reflects light to fall on an eyepiece, and from there we get a magnified image to our eye. Okay. Please go through his working and try to draw a picture of this reflecting telescope and refracting telescope with these light beams. So we are coming to an end of this class. Actually, mirror type telescopes or reflector telescopes are more user friendly because they are not heavy, they are much lighter than lenses. Mirrors are a lot easier to launch into space. Such type mirrors, such type reflector telescopes are more easier to handle, are more user friendly. In most space applications, we are using this reflector type telescopes. Okay. So what here we studied about this telescope. A purpose of telescope is to make things easier to see, to make the invisible visible, and to make things already visible more clearly. Just like our eye do. There is a small sort of lens in our eye too, isn't it? But it cannot gather all the light coming from our stars or galaxies. So we can't see the complete picture of that galaxy or star, or complete picture of the light coming from those stars or galaxies. That's why using our naked eye we cannot get correct information about those galaxies. So we are using or so we are viewing these galaxies using a telescope, so that we could get some more magnified image of the distant galaxies. Thank you.